Assalamu alaikum, I'm Engineer Hamna Shakil. In this video, I will solve problem number 108 that is related to axial stresses. The problem statement states an aluminium rod is rigidly attached between steel rod and a bronze rod as shown in the figure. Axial loads are applied at the positions indicated. Find the maximum value of P that will not exceed a stress in steel of 140 MPa, in aluminium of 90 MPa, or in bronze of 100 MPa. So you've got here an aluminium rod that is rigidly attached between steel and bronze, and on the left side the steel rod is rigidly attached to a support. The area of steel is 500 mm square, area of aluminium is 400 mm square, area of bronze is 200 mm square. An axial load of 4P is applied at the junction between steel and aluminium, and a force of P is applied at the junction of aluminium and bronze, and an axial force of 2P is applied at the free end of the rod. So you have to find a value of P such that the stress in steel does not exceed 140 Newton per millimeter square, stress in aluminium does not exceed 90 Newton per millimeter square, and stress in bronze does not exceed 100 Newton per millimeter square. Let's first analyze this rod globally, and then we are going to analyze each of the section individually. We need to find the reaction of the applied forces on this rod. For that, first we are going to see what the actions are. So here you have got 4P force, here you have got P force, and here you have got 2P force. So if you take the left direction as negative, you will have minus 4P plus P and minus 2P as the action. So you have minus P as the action. Minus P means that an action of 5P force is being applied on this rod. So you will have a reaction of 5P on the rigid support. Now let's analyze each of the section individually. So you have a reaction of 5P at the rigid support. If you draw a free body diagram of steel, you will have a 5P is acting here on steel, so you will have a reaction of 5P here. So you can say that steel is under compression and the compressive force is 5P. For free body diagram of aluminium, you have here you have rigid support, then you have steel, and then you have aluminium. So this is steel, this is aluminium, a force of 5P here, a force of 4P at the junction between steel and aluminium. So here you have plus 5P minus 4P equal to P. So you have a global force of P acting on this assembly. So you will have a reaction of P here on the aluminium. So again you can say that aluminium is under compression and the compressive force on aluminium is P. Then you have got bronze section here. So you can go from the left side or you can also go from the right side. So here it's easier to go from the right side. So let's do that. For bronze, you have a force of 2P acting on it. So you'll have a reaction of 2P here. So you can say that bronze is also under compression and the compressive force acting on bronze is 2P. So force on steel is 5P, force on aluminium is P, and force on bronze is 2P. And all of these sections are under compression. Let's draw axial force diagram of this composite rod. You have a reaction of 5P acting on the rigid support. This horizontal line represents zero force. Starting from the left hand side, this 5P force is a compressive force that is acting on steel. So you can go down 5 units. You have a force of 5P acting on steel. Then you have the same force in steel throughout. At the junction between steel and aluminium, you have a force of 4P acting in the opposite direction. So if this is negative 5P, this will be positive 4P. So you will go 4 units upward. So minus 5 plus 4P is minus P. Then you have the same P force throughout the aluminium. At the junction between aluminium and bronze, you have again a compressive force of P acting. So you can go down 1 unit. So minus P will give you minus 2P. Then you'll have the same 2P force in bronze throughout. And at the right hand side, you have a force of 2P acting here. It has an opposite direction to this force. So you can take it as positive. So minus 2P plus 2P will give you 0 force. So this is your axial force diagram of this composite rod. So steel is having a compressive force of 5P, aluminium is having a compressive force of P, and bronze is having a compressive force of 2P. So now we have all the data that we need to further solve the problem. So you have to find the maximum value of P so that the stress in steel does not exceed 140 MPa, stress in aluminium does not exceed 90 MPa, and stress in bronze does not exceed 100 MPa. The force in steel is 5P, the force in aluminium is P, and the force in bronze is 2P. The area of steel is 500 mm square, area of aluminium is 400 mm square, and area of bronze is 200 mm square. Starting with the steel, so the stress in steel must be less than equal to 140 Newton per millimeter square. Stress is force divided by area. The force in steel is 5P. Area of steel is 500 mm square, and the stress is limited to 140 MPa or Newton per millimeter square. When you solve this, you get P less than equal to 14,000 Newton, or you can say P less than equal to 14 kilonewton. Let's do the same thing for aluminium. So the stress in aluminium must be less than equal to 90 Newton per millimeter square. The force in aluminium is P. The area of aluminium is 400. So P is less than equal to 3600 Newton, or you can say less than equal to 36 kilonewton. Let's do the same for bronze. So stress in bronze must be less than equal to 100 Newton per millimeter square. The force in bronze is 2P. The area of bronze is 200. When you solve this, you get P less than equal to 10,000 Newton, or you can say P less than equal to 10 kilonewton. So you have got three values of P, and you have to select one of them that works for all the sections of this composite rod. If you select P as 36 kilonewton, this is greater than 10 kilonewton, which is a limiting load for bronze, and it's also greater than 14 kilonewton, which is limiting force for steel. So if you select P equals to 36 kilonewton, bronze and steel will fail. So you cannot select this one. If you select P equal to 14 kilonewton, This 14 is less than 36, so aluminium will pass, but this is greater than 10 kilonewton, so bronze will fail. And if you select P equals to 10 kilonewton, this is less than 36 kilonewton and that is also less than 14 kilonewton. So for P equals to 10 kilonewton, bronze, aluminium and steel all will pass. So your answer will be P equal to 10 kilonewton.